Hello students, so we are on strong acid strong base titrations. Plotting of titration curve is the major concern of this video. The calculations involved while plotting a titration curve, a neutralization curve, or pH curve is the concern for this video. And this was the table which was introduced in my previous video, which is showing the values of alkali which is added at the time of titration, and shows the pH condition of the conical flask to which the alkali was added, which was already having an indicator system and 100 ml of HCl with it. During the course of titration, when 50 ml of solution, sodium hydroxide solution was added at the time of titration, the pH was encountered for a 1 molar solution was 0.5. Now, how this 0.5 pH we have calculated it? Here you can see this is a hydrogen ion, will therefore be the concentration of hydrogen ion will therefore be 50 into 1 by 150. 50 is the amount of alkali added, or no, 50 is the amount of hydrochloric acid which is remaining, because it was assumed that it is 100 ml of hydrochloric acid and it is 1 molar hydrochloric acid, and hydrochloric acid is a strong acid and it gets 100% ionized. So when 50 ml of alkali is added to the solution, only 50 ml of hydrochloric acid is left out, which is to be neutralized, and this is the total volume of titrant plus the hydrochloric acid present in the conical flask, which suggests us the value of 3.33 into 10 raised to minus 1. This is the hydrogen ion concentration. While taking, when we take negative logarithm of this hydrogen ion concentration, the value comes out to be 0.48, which can be shown in this table here. 50 ml of volume, the figures have been rounded up for convenience for representation. 50 ml of, when 50 ml of sodium hydroxide solution was added, so the pH of the solution or at that point of time was 0.48, which is being rounded up to 0.5. When 75 ml of this thing was added, sodium hydroxide or the base was added, only 25 ml of hydrochloric acid was remaining, and while the total volume of the solution which was there in the conical flask was 175 ml, which corresponds to 1.43 into 10 raised to minus 1. When taking the negative log of to the base 10 of this, which results in pH is equal to 0.84, which has been rounded up to 0.8 here. And likewise for 90 ml we had pH of 1.3, for 99 ml we had pH of 2, and for 99.5 ml we had a pH of 2.6. 99.8 ml, 99.9 ml. Here is a thing which we have to concentrate on. Here you can see 99.9 ml of solution was added, alkali was added to hydrochloric acid. The pH was 3.3. It was still acidic. As soon as 100 ml of HCl, which is 100% ionized, and sodium hydroxide also, which is 100% ionized, when 100 ml of this solution was added, the pH suddenly shoots up to 10.7, and so on. Like there is a 3 unit change on addition of single drop or 0.1 ml of sodium hydroxide solution to the conical flask. Here you can see pH 1 at the start due to 0.1 molar is around 0.48. Then where there's a very little change in pH during the initial 20 centimeter cube, this is 25 milliliter, and there was a sharp change in pH which was observed on addition of 25 ml. According to this graph and according to the table, 50 ml solution resulted in sharp change in pH, which resulted from 2.5 grossly to 10.5 to 11. So this is a very sharp range in pH over addition of less than half a drop of pH, and curve levels off at pH 13 due to excess of 0.1 molar or 1 molar alkali. So in the following examples, alkali 0.1 molar is added to this. Endpoints need not be neutral due to the phenomenon of salt hydrolysis, and Initially there was very little change, very sharp change was observed at the end point, and so we can conclude that these all the three types of indicators, that is methyl orange working in acidic range, litmus working in neutral range, and working at the basic range is phenolphthalein indicator, can be used in strong acid, strong base titrations. By plotting this neutralization curve by calculating the values of pH on addition of alkali, we can find out the shape of neutralization curve, the steepness or the sharpness of neutralization curve, and thereby suggesting the choice or governing the choice of indicator system for that particular strength of acid or base in the titration which is used. This was the major concern in the video, and this finishes our strong acid, strong base titration, resulting in the conclusion that phenolphthalein, methyl orange and litmus, all the three indicator systems can be used to detect an endpoint when titration is done with strong acid and strong base. Thank you.